Assalamualaikum Miss, I am Nur Izzatul Qaimah binti Ahmad from EH1104A. I am going to present on my prelab on gas absorption based on experiment 4, which is the effect of inlet gas on carbon dioxide absorption. So now I am going to proceed on the theory of the experiment. Gas absorption is an operation in which a gas mixture is contacted with a liquid for the purpose of preferentially dissolving one or more components of the gas mixture and to provide a solution of them in the liquid. There is a mass transfer of the component of the gas from the gas phase to liquid phase through an interface, which also known as two-film theory. Two-film theory in the gas absorption process should have this following requirement. First, the concentration gradient must occur to cause the mass transfer. Second, the concentration of the gas YA is higher than the concentration of the gas at YAI at the interface. The concentration of XAI is higher than XA. So next, I am going to proceed on the objective of the experiment, which is to study the effect of water flow rate and inlet gas composition on the efficiency of carbon dioxide absorption. Next, so now I am going to proceed on the general description of the PFD on the gas absorption unit. Air and carbon dioxide are mixed before it is fed into the bottom of the pack absorption column, while water enters from the top of the column through a centrifugal pump. The transfer of carbon dioxide from the air mixture into the water occurs when gas and liquid are brought into contact. The lean air mixture will exit at the top of the column, while the CO2 rich water will accumulate at the bottom and overflow into a receiving vessel. So now I am going to describe on the equipment available in the gas absorption process. First, the receiving column, which is B1 and B2, a 50-liter cylindrical vessel equipped with a charge port and venting. The second one is the absorption column itself, the N80 pack column with glass gasket, rings, inlet and outlet connection for counter current gas and liquid flow. Effective column height of the column is 1500 mm. The third one is the centrifugal pump in the gas absorption unit. Centrifugal pump with maximum delivery of 60 lpm at the maximum delivery height of 6.3 meter. So now, based on the same PFD available, I am going to explain on the operating procedure. First, general operating procedure. Prior to operation, it is important that the user read and fully understand all instruction and precaution stated in the manufacturer manual supplied with the absorption unit. So, I am going to explain on the general startup procedure. Ensure all valves HV are closed except the ventilation valve, which is HV13, is fully open. Drain any stagnant liquid above the sampling valve, which is the HV03. Open the valve at the compressed air and CO2 supply area. Set the pressure of air supply to 0.2 megapascal and pressure of carbon dioxide supply is 2 megapascal by turning the regular knob clockwise. Lastly, turn on the main switch. For the general shutdown procedure, first we need to turn off the pump 1, then we need to close the water supply and valve HV01, HV02 and HV11. Alamak. I'm sorry, HV11. The third step is to drain all liquid from absorption column K1 by opening the valve of HV03. The fourth step is to drain all liquid from receiving vessel B1 and B2 by opening valve HV07 and HV08. The next step is to close HV03, HV04, HV05, HV08 and HV10. Next, close all the valves of HV12, HV14, HV15, HV16 and HV7. HV17. Okay, next, ensure that HV13 is fully open. Then we can turn off the main switch. Okay, that's all for the general startup and general shutdown of the process. So now I am going to explain on the experiment procedure. First, perform the general startup procedure as I have described before. Open valve 12, valve 13, valve 14 and valve 15 and valve 16. Okay, fill the feed tank through the charge port with 30 liters of water by opening valve 04, valve 07 and valve 17. The third one is to open and adjust valve 01 here, which is the air supply, to give a flow rate of 30 liters per minute air into column K1. Next, open the valve HV10 and valve HV09 slightly. Switch on pump 1. Observe the flow of water from vessel V1 to pump 1. Slowly open and adjust HV11 to give a water flow rate of around 1.5 liters per minute. Observe the water flow rate indicate an FT303 at the control panel. Allow water to enter the top of the column K1, flow down the column and overflow back into vessel B1. Then collect initial liquid sample of 100 ml from valve HV03. Next, open and adjust valve 02, which a CO2 supply, to give a flow rate of 3 liters per minute of carbon dioxide into column K1. Next, let the process run about 5 minutes to allow the absorption column to be stable. Start collecting liquid sample approximately 100 ml from the outlet of the absorption K1 from valve HV03 at every 5 minutes. At the same time, record the outlet CO2 composition shown by QT401 at the control panel. Continue to collect the liquid sample and record the outlet of carbon dioxide composition at every 5-minute interval until there is no more changes in the carbon dioxide composition over time. Analyze the collected sample to determine the composition of dissolved carbon dioxide. Next, throughout the experiment, monitor and maintain the air, carbon dioxide and water flow rates by adjusting the appropriate valve on HV01, HV02, and HV11. Next, repeat the experiment step 2 to step 12 by using water flow rate of 1.5 liter per minute, air flow rate of 30 liter per minute, and carbon dioxide flow rate of 6 liter per minute. So next, I am going to explain on the liquid sampling procedure for the process. First, drain any stagnant liquid above the sampling valve. Next, open the sampling valve and collect about 150 ml of the sample. Next, place a vial below the sampling valve. Then, close the sampling valve. So, next, I am going to explain on the analysis of dissolved carbon dioxide in water, which is the procedure itself. First, obtain a sample from the section 4.4, which I have explained before. Then, prepare exactly 50 ml of the sample in a conical flask. Add 3 to 5 drops of phenolphthalein indicator. If the sample turns red immediately, no free carbon dioxide is present. If the sample remains colorless, titrate with 0.05 mole sodium hydroxide standard solution. Then, measure the volume of 0.05 mole sodium hydroxide required to reach the endpoint. The endpoint occurs when a definite pink color persists in the solution for longer than 30 seconds. For the best result, use a color comparison standard. Prepare exactly 100 ml of 0.01 mole NaHCO3 solution in a conical flask and add 3 to 5 drops of phenolphthalein indicator. So next, this is the formula used for the process in the experiment. To find the volume used is final volume minus the initial volume. To find for the volume of sodium hydroxide used times sodium hydroxide concentration, we can get the number of mole of carbon dioxide consumed in mole. As to find for the concentration of carbon dioxide is equal to number of mole of carbon dioxide divided by the sample volume. So, this is the last one, which is the expected result. From the experiment, I am expecting to achieve the main objective, which is to study the effect of water flow rate and inlet gas composition on the efficiency of carbon dioxide absorption. Other than that, the flow of the components in the gas absorption, which is in countercurrent direction, enable the process to be more efficient and achieve the main purpose of the process itself, which is the occurrence of mass transfer between gas and liquid. That's all for me. Thank you.